Hello to everybody. I'm happy to greet all the participants of the International Conference on Science and Technology Research. My name is Liudmyla Gryzun. I'm a full professor of Information Systems Department, Simon Kuznets National University of Economics, Kharkiv City, Ukraine. I'm also a president of STRA Association, Eurasia Research. The topic of my keynote presentation is Petri nets as a tool for university curriculum modeling. In terms of self-introduction, I'd like to say that my scientific activity is focused on curriculum design in higher education based on scientific knowledge integration, assessment of pedagogical projects, and some other branches. However, the focus of my scientific activity is coordinated curriculum design in university education based on knowledge penetration. So the topic of my presentation today is not occasional, and I'm going to cover the problems of university courses synchronization, to present the author's approach to the curriculum modeling using Petri nets facilities, and to discuss the benefits of the offered approach. So, the problems of university courses synchronization, in fact, are caused by the number of factors which demands the search of new approaches to the curriculum design. In particular, among these factors, the quick changes and renewing of technologies, social life, situation, and employment market, the international students and employees mobility, which leads to the necessity of design of international context of higher education. The growth of information amount, knowledge expansion, renewing of knowledge, losing its urgency very quickly, etc. And definitely the trends of contemporary scientific branches, which are synthesis of knowledge, mutual enrichment, interdisciplinary research with interpenetration of knowledge and cognitive method tools, etc. So all these tendencies must be reflected in the content of training of university students, because global science and employment market demand specialists who are ready to solve integral problems, not a specific one, have flexible system of knowledge, who are able to use knowledge in a related branch and are able to adapt quickly to changes, to retrain, to reorient their qualification, etc. In terms of globalization process and permanent changes in science and industry, building of worldwide curricula is getting really urgent. Its development has expanded the scope of the university disciplines, and it raises the task of preserving the natural links between the disciplines, integrating of the newly appeared disciplines into the existing curriculum, the synchronization of their mastering, etc. In the terms of challenges of specialist training and university curriculum design, it's relevant to mention the position maybe and the role of discipline itself and its structure. The matter is that the curriculum discipline, on the one hand, is implementation of certain educational content, and a relevant modular structure of a subject can facilitate the processes of formation of holistic and flexible system of students' knowledge and skills. On the other hand, any curriculum discipline is an embodiment of some scientific branch adapted to teaching and learning. Hence, it must reflect correctly the branch structure, preserving main links between notions, concepts, facts, theories, which really exist both inside the academic branch and between sciences in a whole. It causes challenges of specialist training. For example, if you talk about IT specialist training, so we have to mind that there are important pillars as the guidelines for curriculum building in university education. It has to preserve the concept of computing, for example, throughout the world and in time, as well as to support existing, emerging, and future computing disciplines, both for the today and potential students. It also has to mind future trends and achievements from industry research and the entire spectrum of society. It must be also flexible to the global enduring acceptance and adaptable within multiple educational contexts. Actually, these ideas also true for university curriculum of other specialist training, not only for IT specialists. So the main problems to be solved are how to form integrative content of learning, how to provide modular structure and of curriculum disciplines with preserving links between knowledge, and how to provide also the synchronized learning throughout the modules of different curriculum disciplines for preserving specialist training. So it's clear that it's necessary to develop some alternative approaches to curriculum discipline based on some mathematical and digital tools, which are able to, first of all, overcome the exposed problems, to cultivate cross-disciplinary strategies of teaching and learning, and to form students' holistic, coherent, and flexible system of knowledge. So, if to characterize our author's integrative approach to curriculum design, I'd like to say that it is based on the relevant revealed mechanisms of knowledge integration in scientific branches and curriculum design. It provides techniques for discipline structure, which triggers the integration mechanisms realization, and it results finally in the coordinated system of curriculum disciplines, preserving links between knowledge and making positive impact on the trainees' system of knowledge. The technique of curriculum discipline structure, which must be done in order to get the modular structure of curriculum subjects, keeping and spreading links between knowledge both inside and module and between modules and subjects of curriculum. It was based on the ideas of the multi-level construction of the content of learning, multi-level knowledge generalization, and using the models of knowledge representations of the artificial intelligence theory. In particular, it was used semantic networks and frame-based systems. Multi-level construction of the content of learning covers four core stages, so-called super-discipline level, the level of curriculum discipline, the level of learning material of the curriculum discipline, and the level of learning activity, when the educational content is implemented into the activity. So at the first stage of the discipline structure, and the so-called super-discipline content is concentrated as a network of key points defined based on the analysis of the system of professional functions, the structure of the activity, essence of the typical professional tasks. So they include real objects, processes, phenomena which are to be mastered by pre-service specialists. The second stage of the discipline structure, and it is so-called structure level of knowledge generalization. It provides general structure of the subject area and rules of knowledge manipulation. In order to realize it, we elaborated special technique of preliminary analysis of the subject area and revealing the didactic characteristics of academic disciplines. After such an analysis, we could select note learning elements of the subject domain around which we should concentrate learning material at modular structure. Also, we match node learning elements to the key points of the highest level, and these ideas are shown here on the scheme. At the second stage of the discipline structure, that is the level of curriculum subject and the hierarchy structure with frames in its nodes is built. Each frame corresponds to the cycles of training, to curriculum subjects, to the modules with learning elements in the nodes. And after that, on the third stage, of knowledge generalization. We fill in all three prototypes of general structure and their slots with exact data, exact values of learning elements, exact inheritance pointers for each slot to provide proper links. Finally, we obtain the coordinated and coherent system of curriculum subjects. And here you can see so common view of this system, and finally we obtain in such a way the system of curriculum subjects based on the frame system and semantic networks, and all the changes which happen on the superdiscipline level immediately are spread via the learning elements through all the system of modules of all the disciplines. In such a way, we obtained a really sensitive and flexible system. This technique, which I have presented to the discipline structure and coherent curriculum shaping, was implemented and verified. However, in the process of real curriculum building, it became clear that it is necessary to elaborate the issue of the grouping learning elements into the frames, because it's essential to group them, taking into account also the sequence and precedence of their learning within the modules and disciplines. And it will make their mastering not only holistic, but also synchronized. In terms of synchronization, it's important to use relevant mathematical apparatus and relevant instruments. And one of them is Petri nets, which was used as a university courses modeling instrument. Petri net can be defined as a two-part oriented graph where P and T, so places and transitions, are finite, not empty sets of graph vertices, among which there are distinguished two types of vertices: places, which are circles actually, and transitions, which are bars in the net. R component determines a relationship between the vertices corresponding to the arcs. The places also can accommodate tokens that can move around the net via transitions, and in such a way, in fact, we can model the dynamic of processes. The preparatory stage of modules modeling, we distinguished learning elements which are inputs and outputs. Inputs can be interpreted as the learning elements which are necessary for the student to master in order to be able to learn the learning elements of the frame, other learning elements of the frame. In similar way, the outputs can be interpreted regarding the other frames. For inputs and outputs, they will determine the types of precedence relations of the frames. For inputs, they will determine three types of relation: one-to-one, and two more, so-called or precedence relation and end precedence relation. And for the outputs, they will also determine two types of relations: one-to-one and one-to-key elements. Using these precedence relations, we could simulate learning elements, frames composed by learning elements, and finally curriculum disciplines composed by the frames through Petri nets. So here you can see Petri net modeling, so-called basic Petri net modeling for a learning element mastering by the students. Petri net, which simulates a learning mastering by the students, is presented by 4 places and 8 transitions. The places represent the states of learning elements as for their readiness to be learned by students due to their relations precedence. There is also one and only one token in the net, which means that only one of these places can be marked at a time. The transitions simulate the events of start of learning elements mastering, the process of its learning regarding the academic time and its availability due to its precedence relations, and finally accomplishing mastering. And the next step of modeling such basic Petri net was used to create a frame model, which in fact a course module. It was composed by a set of the models of learning elements connected dependent on their precedence relations determined above. This composition was done by merging transition T1, which interprets that this learning element able to start of dependent module, and transition T8 of previous model. There are three situations how to add and how to compose the learning elements to create a frame. And these three situations are presented here as so-called one-to-one precedence, n-to-one precedence, and one of n-to-one precedence, which interprets as OR operation. And in similar ideas were used for Petri net's modeling of the whole course. The Petri net representations of the two modules are presented by common Petri nets after applying the rules presented before using the net addition operation, considering AND precedence for A variant and OR precedence for B variant. Using the operations of Petri net's modifications, in particular the fusion and learning elements connections of different types depicted above, we could obtain a model of curriculum discipline module and finally a curriculum discipline model. It's essential to note that output transitions of each learning elements model can trick the subsequent learning elements model only if the previous, in terms of precedence relation learning element, is accomplished. It is guaranteed by the rules of Petri net execution and modifications. So, as a result, the built Petri nets represent all the evolution of the learning elements mastered by the students in the frames and between them. Petri nets facilities provides grouping learning elements into the frames, which are modules of the discipline, in fact, taking into account precedence of their learning. Frame facilities provide spreading the set links between the learning elements within the module and between the modules in different courses. So such a modeling for shaping the frames, which are modules of the disciplines, provides synchronization of learning elements mastering and at the same time keeping links between them. So, in terms of the benefits of offered approach, I'd like to say that in such a way, we can realize mechanisms of knowledge penetration in the curricular subject. We can optimize sequence and coherence of learning, mind the discipline's evolution and the pair and new ones with their including into the flexible curriculum, excluding their unnecessary repetition and academic time saving. The obtained curriculum with our simulation is flexible to account both global acceptance and national educational context, etc. Also, such an approach to the curriculum modeling can be used in the software for automatic creation of a holistic and synchronized curriculum, which makes prospect of our research. Such a software will allow to detect which proper learning element and where has to be mastered, to trace the learning elements which have been mastered and will be necessary for mastering other set of learning elements, and to build individual study plan for students, to personalize curriculum, and so on. For university teachers and professors who are potentially going to use such ideas, it allows them to see and realize the place of each learning element in the system of learning elements of the discipline in a whole, and it links with other disciplines via mutual penetration, and hence to select proper methods and techniques of learning, to offer students interdisciplinary problems to solve, to propose special ways of students' activity in order to form their holistic and flexible system of knowledge and skills, and definitely to save academic time, and at the same time to learn each learning element comprehensively with students, deeply, and from the standpoint of various disciplines. So thank you for your attention. I'm ready to answer your questions, and we can contact via my email, for example. Thank you kindly.